Welcome. This is the Regression Analysis course. My name is Nicoleta Serba. I'm an Associate Professor in the Stewart School of Industrial and System Engineering. The lecture is Multiple Linear Regression with a focus on multicollinearity with the data example. In this lesson, we'll learn how to identify multicollinearity with the R statistical software with a data example. We'll return to the example where we're interested in the relationship between the advertising expenditure and sales in the presence of other predictive variables that impact sales. The questions that we'll address in this example are as follows. What are the correlation coefficients between the quantitative predictive variables? Any potential collinearity? And I will also illustrate how to estimate, how to obtain the variance inflation factors, and whether we can, and we also will identify multicollinearity with those factors. And we'll also look at the interpretation of the coefficient of variation. In order to compute the correlation between the predictive variables, we can use the COR, the core command in R, which stands for correlation. Here we're going to input the matrix where the columns of the matrix are the four predictive variables. And what we see here is the matrix of the correlation values. For example, the value 0.418 is the correlation between advertising expenditure and amount of bonuses. The maximum correlation between predictive variables in this across all four predictors is 0.452, so it's not a very strong correlation among the predictive variables. If we want to compute the VIFs for each individual predictor, we can use the VIF command in R where the input is the fitted model. And what you need to focus is on the first column of values, which are the VIF values. Now we can compare the VIF's values with the threshold, which is maximum of 10, maximum between 10 and 1 over 1 minus r squared, which is actually 10. And we can see that none of the values, the VIF values, are larger than 10, which is an indication that we don't have multicollinearity in this example. If we were interested to obtain the r squared, we can use the summary of the fitted model and specify that we want r squared from this summary. And the coefficient of variation is 0.955, which means that the model, the linear regression model, explains 95.5% of the variability in the sales. In summary, in this example, I illustrated how to identify multicollinearity with a data example. Thank you.